Olive oil is one of the most common oils that people like to use on this earth, especially in household settings. Many people will use olive oil to fry certain things like eggs or chips, anything that can potentially be fried. A lot of households will use olive oil, especially in the UK and Western countries in general. However, industrial companies, big, large conglomerates, they will use things like sunflower oil or vegetable oil because they are able to be produced at so much cheaper than olive oil. They can be stored in any way, shape or form they want. You may notice that olive oil, whenever you buy olive oil, sometimes it's in glass, sometimes it's in sort of harder plastic than what you see in the sunflower oil, vegetable oil things where it's really compressible, whereas the olive oil ones are less compressible, or it's in glass. They'll always have like a dark tinge to them because the light, the photosynthesis, the photons from the light will actually be able to damage the oil itself, so it has to tinge it in a darker way so it can reflect more light off rather than oxidize and do a load of bad things to the oil that wouldn't be good for you when you ended up having to use it later down the line. Sunflower oil, vegetable oil doesn't have this problem, so of course industries and companies choose to fry their stuff in that sort of method because it's a lot cheaper. Trouble is that does end up having lasting impacts on our health. Polyunsaturated fats, which are the majority component inside of sunflower oil and vegetable oils, are more likely to oxidize when like put under heated conditions. The deep fat fryers, if you compared a deep fat fryer that's full of polyunsaturated majority sunflower oil to monounsaturated majority olive oil, you would see, if you sort of did a chemical analysis, the frying of the chips in one or the other, that the one that's being fried in vegetable oil would produce a lot more toxic chemicals that aren't just the things like trans fats. They produce a lot more free radicals that aren't good for your health, and while polyunsaturated fats will produce more trans fats than monounsaturated fats, it also produces a wider variety of chemicals due to the fact that it contains more double or even triple bonds, which ends up making it that bit more unstable. But olive oil, in terms of its physical properties, is quite a viscous oil. It's very thick. It's not like the polyunsaturated oils where you can pour it out and it almost acts physically like water. Olive oil is a lot more viscous, acts a little bit more like milk or cream or something that's a bit more thick, or gravy, for instance, something like that. Butter, which is majority components saturated fats, it's solid. And the reason that it's solid is due to the way that polyunsaturated fats and monounsaturated and saturated fats are structured. If you imagine the saturated fats, it's all completely straight lines. There's no bending in the chemical structures. So when these are packed tightly, it will make a more solid structure because it is able to be packed tightly. When you imagine monounsaturated, like the majority component of olive oil is, it can bend sometimes it doesn't, and they will have saturated and polyunsaturated. And that means that while it won't be as sort of liquid as the polyunsaturated fats, nor as solid as the butter, it still has that sort of thick, viscous sort of physical component and physical characteristic because of its chemical composition. And obviously with polyunsaturated fats, all the chemicals are quite curvy. They have a lot of double bonds, triple bonds even, and that's going to mean that all the molecules don't fit into each other as well as it will with saturated fats, and so it like sort of acts physically more like something like water would. But the question that I want to ask for the rest of this video is, what fats are contained inside of olive oil? Olive oil, if you compare olive oil to an apple, right? Olive oil, the only macronutrient that it contains is fat. It only contains fatty acid as things that can be used to produce energy. Whereas apples, they have fats, proteins, carbs, fiber, a load of other stuff, and contain a lot of phytochemicals. While olive oil contains a lot of phytochemicals, it will have them in a lesser sort of component as part of its as part of its product, because it isn't a whole food. It has been through a process to get to olive oil, whereas apple is a whole food, so it contains a lot more chemicals than olive oil does because it hasn't had some of those chemicals removed in all of its chemical processes. But fats, in terms of a macronutrient, are also a lot easier to understand. The only functional group that it has is a carboxylic acid group, which defines it as a fatty acid, and then it will have its hydrocarbon chain, which can contain either just a straight saturated hydrocarbon chain. It can either contain maybe double bonds, which would make it unsaturated, or it can maybe even contain triple bonds. If it contains just one triple or double bond that makes it monounsaturated because it is unsaturated by one time. Polyunsaturated means it's going to contain multiple double or even triple bonds, and the instability of these double and triple bonds is the reason that things like butter and lard are potentially better options to fry things in, not necessarily eat in terms of your cardiovascular health, but when it comes to frying, they are 100% the better option to use because they are more stable as a chemical itself. Now, olive oil, if you imagine all the fatty acids inside of olive oil, what types of fatty acids are actually inside a specific bottle or glass of olive oil, excluding all of the phytochemicals that are contained inside of olive oil because they are not specifically relevant to what I want to talk about in this video. Oleic acid is the fatty acid with the highest majority composition inside of olive oil, containing either 55% of olive oil or around 83%. Now, no bottle of olive oil is going to have the same composition of fatty acids or any other sort of phytochemical that exists because they're all different. They're derived from different types of olives. They are produced by different manufacturers. So 55 to 83, while being quite a big range, is probably quite an accurate range. And I doubt there are many olive oils out there that go either to the extremes of the spectrum and beyond. So if you sort of take a middle point of the oleic acid, it will probably end up at around 60 to 70 something. And if you take the middle points of all the percentages that I've done in this video, it should hopefully end up adding up to around 100 if my math is correct. Probably it isn't, but who honestly knows? Now, the second most common fatty acid is palmitic acid with a composition of from 7.5% to 20%. Now, if you take an average, that's going to end up being around 14%, and add that to 60, you get something in the region of 80% of fatty acid composition so far. Third fatty acid, you have linoleic acid. This has quite a big range. It can either be from 3.5 to 21%. So while some olive oils will potentially have more linoleic acid than palmitic acid, I decided to take palmitic acid as the second most common because in terms of range and in terms of how many olive oils have more palmitic acid than they do linoleic acid, I assumed that palmitic acid would probably be more common in that department. Now, the fourth most common acid inside of olive oil is palmitoleic acid. You see the similarities between oleic acid and palmitic acid there. This can range from 0.3% to 3.5%. Again, take a middle point and add it to the rest of them. It should be getting close to 100 by this point. And the fifth most common is alpha-linoleic acid. The alpha meaning that either its double bond is positioned in a slightly different way, because I'm pretty sure alpha-linoleic acid is either omega-3 or omega-6. Not entirely sure which one it is off the top of my head. So it might be a repositioning of the double bond compared to linoleic acid, or it is an addition of of the double bond to linoleic acid, and then things like beta and gamma linoleic acid are rearrangements of said double bond. Now, in olive oil, alpha-linoleic acid can range from 0.5 to 2%, and the sixth most common fatty acid inside of olive oil is gadolinic acid, which can range from around 0.25% to 1.5%. Now, that is the total fatty acid composition of olive oil. If you add up the midpoints of each of these sort of ranges, should be getting close to 100, shouldn't be over, because even if it's like 99 point something, there's going to still be more fatty acids that exist inside of the olive oil, but obviously they're going to be hard to detect because there is such a minuscule quantity of them, and they're also not necessarily relevant in the quantities that they are to potentially human health and stuff. There's probably going to be loads of other fatty acids in such minute quantities out there, but it's hard to find research on them because not many people will have done research on such a thing that is not really that relevant to what humans want to actually do with their scientific research in the future. Now, olive oil with composition is so much simpler to something like apple, which will have things like vitamin B12, will have things like vitamin D, and while olive oil can help the absorption and the usage of fat-soluble vitamins like vitamin D, K, E, and A, apples are going to have things like vitamin B12, which literally contains a cobalt sort of elemental part inside of its structure, which is very interesting. But that's about all I have. Now you may know what fatty acids are inside of olive oil, which could be an interesting thing for you to know, as well as a few tips and tricks on frying and all that other stuff. But with that, I recommend subscribing because I like this community of young tribal people who are willing to improve themselves so much more than you already have, and good luck.